Pre-Calc 12s, this is the first section of the entire course, which is section 1.1. Topic covered today will be horizontal and vertical translations. So first off, we're going to start by looking at some vocab words for this section. The first word we're going to look at is transformation. So transformation is a change made to a figure or a relation such that the figure of the graph of the relation is shifted or changed in shape. So on the right here, I'm just going to draw a picture of a function. So if we have this particular function here, I'm going to just copy it and then paste it. One type of transformation is shifting it around. So just, moving it all around the graph. I'm just going to have it stop up here. Okay, so that is a type of transformation. Well, if I paste another one, well, what else I can do is also I can stretch it horizontally and stretch it vertically. That is also a type of transformation. Okay. And something else that I can also do is I can flip this round, and I'll just leave it here. And this here is also a type of transformation. So again, as long as you are changing it from the original through either stretching it or rotating it or moving it, those are all different types of transformations. You're doing something with an original function or figure. Next is the word translation. Translation in a math context means slide transformation that results in a shift of a graph without changing its shape or orientation. So right now, I'm just gonna draw an arrow here. It's gonna point here. I'm just gonna say this is the original because they're all starting to look the same with this blue color. So from the original, we have kind of three different graphs that have come from it, three different transformations. Now let's take a look. So with the first one here, this one, with our definition here, it did what we call a reflection. It did change its orientation. It doesn't kind of go up to the right like its original. So this is not a translation. This one down here, well, this one, the shape has changed. It has stretched horizontally and vertically. So that is also not a translation. Now this third one here, I'm gonna actually highlight it this way. Well, this one and the original is the same shape. It has simply just moved up and to the left. So those two are examples, or this one here, actually not the two. The one at the top here is an example of a translation. Okay. Third word is the word mapping. So mapping is the relating of one set of points to another set of points so that each point on the original set corresponds to exactly one point in the image. So right now we have kind of shown, well, graphically how it has transformed, but through mapping, we can actually just plot out every point that has changed from the original. So what that will look like is the following. So to show the points on a graph, you would have to know the X and Y value, or what we call an ordered pair. So this part represents the original right here. And after transformation, the X value will change in some way. So just point out, remember X value is the left to right kind of axes, the horizontal axes, and the Y value is up and down, also known as the vertical axes. So the X value will take care of anything moving left and right, And we say that is affected by some h value. You could think of h as horizontal, h for horizontal. Now, y is going to be affecting moving up and down, and that is affected by some k value. So let me just write that down. H will talk about horizontal, and that is left and right. K is vertical, which is up and down. Okay. So looking back to our original graph here compared with our translated graph, let's use this as an example. So I'm just going to an example. So let's just say we're just going to compare this point, that point that was at the origin, compared with the same point on the translated graph. We'll say that this point here is actually at -5. We'll say if you go look at it horizontally, this is actually at 3. So we know the point has moved 5 left and 3 up. So the original was at some xy value. All the points on this particular figure has moved 5 to the left. So the h value is going to be -5 because it's left. So it's going to be -5. And it has moved 3 up. So remember, positive is up, negative is down. So y plus 3. And this is how I would show mapping for my example up here. Okay, so now we're just going to look at some examples with functions that you should be familiar with. The first function we're going to look at here is something you have looked at many, many times in PreCalc11, which is this. This, if you have forgotten, is called a parabola. Okay, x squared. And if you have forgotten how to graph this, we can easily use a table of values to help us out. So we're just going to pick some values to put into our equation. So x is our input, remember? And when we put these numbers in, you should know that the output would be 9, 4, 1, 0, 1, 4, 9. So let's just graph that. I'm actually going to zoom in a little bit here. Can I zoom in? Oh, there we go. Ooh, it's really big. Okay, just going to zoom in here so I can get a little closer. Here, 1, 2, 3, 4, 4, 1, 2, 3, 5, 5. Did I get that right? Yeah, good. Okay, remember with the parabola, it is a curved line. So please do not just connect the dots, okay? It should not look like a pointy shape. It should be curved, something like this. Okay. Next, I'm going to graph the next one in blue. Now, here is where you need to kind of look back at PreCalc11 and fish your memory for how to graph this one. So this one here, when you have a number inside the square with your x, it means you have moved your graph, shifted it to the left or the right. But you need to remember when it's inside the square, you need to look at the opposite value. So if it's a negative or if it's -2, it actually means it moved to the right. If it was +2, it actually means you moved to the left. So let me just write this out. So in this one, you actually moved to right because it's -2. So from the original, everything has moved 2 to the right. So the vertex is now here. And then again, you'll just continue your drawing like so. Okay, so yeah, you just connect all the dots here. Oh, okay, let's connect them all. Voila. Okay, so since the last one, you're moving 2 to the right, Well, if you're going to have x plus 3, then you probably figured that you're moving this one 3 to the left. So that one would look something like this. So I'm going to actually go 3 to the left. And then 1, 1, 2, 4, 3, oh, no, 3, 9. Kind of go up like so. Okay. So it's going to look like that. Okay, so that is kind of what has happened here. So that first graph that we graphed in black, as you can see, the x values have not been affected in any way. So therefore, we call this what we call a base function. So it's something that has not been transformed in any way. Now, base function sometimes is also represented by y equals to fx. That fx just represents some function which has not been translated. So looking back at this blue graph, since we moved 2 to the right, if we think back to mapping, when we have our x and y value, we have moved 2 to the right. So that means our x value has been affected. And since it's 2 to the right, it's a plus 2. So it's going to be x plus 2. Didn't change anything up and down, so y will just stay as is. As with the green graph, again, from the original, we have moved 3 to the left, so that's why it's minus 3, but didn't really change anything up and down, so that is just a y. Okay, so that is how you would show the mapping for these two particular functions. So since we were moving things left and right, and we did not change the shape of the function, therefore this is called a horizontal left and right translation. And if we're going to show how we have transformed the function, horizontal translations are specifically y equals to the function where the input specifically has some h value that has affected it. So it's inside the function where the input is affected. Now, one thing you have to be very mindful of is this negative sign. Please be mindful of that. So if h, so if you're moving things to the right, oh, sorry, no, I mean if you're moving things to the left, so if h is negative, so you're moving things to the left, then the h value, if it's negative, then you will have to change to plus. That's a plus sign, okay? Because we have minus and h is negative, so minus negative will give you a plus. So that's just one thing you have to be mindful of. Okay, let's just look at some other examples here. So in black here, we have another base function. This one specifically is called, if you recalled, this one is absolute value. Okay, that's what that function is called. If you forgot what that may look like, again, we can do a table of values. 1, 2, 3. 3, 2, 1, 0, 1, 2, 3. With absolute value, basically, if you have a negative input, that output will just be changed to the positive side. And if you graph this, I'm actually going to make this graph a little bigger again. So we have, let's just plot out the first 3 points actually. So you'll notice that it's a V. This time, you do not need to curve anything. It is purely a straight line. If you have a ruler, please use it. Don't freehand it like me. Okay, so that is the original. Now, looking at our next one, so we're going to graph this one in blue. If you think about it here, with our input, so if x squared gave us, or sorry, not x squared, if absolute value x gave us the values here in black, then, well, if we have our blue function, then everything must just add 2. So instead of 3, we now have 5, 4, 2. Oops, can't add here. 3, 2, 3, 4, 5. So everything has just basically moved up. So we start at 2, 3, 4. All right, everything will just add 2. So you'll have the same thing and everything has just moved up too. So your graph will look something like this. Now, if the base graph plus 2 gives you that, well, let's look at this next one. Now, we have to be careful before we start this next one because with functions, you want to have that y by itself. But right now it's not. There's that 3 on it. So you'll actually need to move this 3 to the other side. To move it, you'll have to subtract 3 from both sides. I'm just writing it out to show you. You do not need to write all this down. So you'll have y equals to absolute value x subtract 3. So if absolute value x plus 2 is moved 2 up, then absolute value minus 3 must be moving 3 down. So we're just going to move all those key points from the original down. And you're going to have a graph that looks something like this. Okay, so these are the 3 graphs. Now let's just quickly look at the mapping for these graphs here. Again, from the original. This time we haven't moved anything left and right. So x stayed as is, but y moved up 2, so it's plus 2. Oops, need to go to green here. So for the other graph, well, we have x and y. X again did not move, but y did move down by 3. So therefore, that's what the mapping would look like for these 2 graphs. Okay, moving on. So since we move things up and down, this is vertical translations. And unlike our first one here, we have our function. Don't change anything with our input, but we do add some value outside the function. So remember, when you're moving things up and down, the letter k is used. So from the function, you add some value k, that will move things up or down. Or another way to actually write this is to move the k to the other side of the equal sign. So you may actually also write it this way, where the function is your y value minus k. Just one thing to be mindful of again, here, watch out for the negative sign. Negative sign. Watch out for that minus sign, okay? So if you're looking at this option on the left, the k value is just going to be, if it's positive, it's moving up. If it's negative, it's going down. But if you're looking at this right option, you do need to make sure you kind of look at the opposite again. Okay, so we've looked at it separately. Now let's move on to looking at translations, vertical and horizontal together. So looking at here, you may recognize that the base function in this one is a y equals to, oh, I keep on wanting to say square root for some reason, absolute value x. But in this particular case, we do have this number here and that number there, which is going to change our base function. In this case, translate our base function. So this -4 here is going to be our h, and our +3 is our k. So remember, with h, if it shows -4 here, the h value is actually just a +4. You always have to find the opposite if it's in the function, okay? And the k value is 3. When you have a positive h, it means you're moving to the right 4. And if you have a positive k, it means you're moving up 3. So if we're looking at it in a translated way, so let's show the mapping. I'm going to show the mapping in blue. So from the original xy, we have moved 4 to the right, so that means x plus 4. And we moved 3 up, so y plus 3. That's how you would show the mapping for this particular function here. So I'm just going to graph the original first in black. The absolute value, you guys should know now, is just going to be kind of this 45-degree line from the origin up to however far you can draw. Now with the mapping, with our translated mapped function, this is what it's going to look like. You're going to move 4 to the right, and then you're going to move 3 up. So you're moving to here. So from there, you're going to graph it. Okay. Probably just do one side at a time. So that blue one there is corresponding to the graph that we're supposed to draw. So that is that one there. Okay, so now that we've gone from function to graph, we're going to do an example where we're going the other way. So the function f of x is translated to give you g of x. So since f of x is translated to give you g of x, so f of x is our original. So how did one get to the other? So now we need to kind of figure out what kind of translations, and then we'll put it into a function. So from our picture here, we're going to just describe the translation that has been applied to the graph of f of x to obtain g of x. You will see this word describe a lot. When I say describe, what I mean is use words. So actually, specifically, tell me in words what is going on. So from f of x to g of x, what you want to do first is to find 2 points that are the same part. So for example, I have this point here, which corresponds to that one, you know, there are basically, let's see, 1, 2, 3, 4, 5. There's 6 different key points here. So key points are points that are clearly on kind of intersecting coordinates, and they have moved from one spot to another. I'm just going to compare this spot that's furthest to the left on both graphs. And as you can see, we have moved 4 to the right, and then you have moved down 1, 2, 3, 4, 5, 6 down. So 4, I'm going to make that line, and then 1, 2, 3, 4, no, sorry, 5 down. So let's just write that into words. So when you're going to describe this, how I'll write this is, since you're moving 4 to the right, it's going to be horizontal translation 4 to the right. Next, since we're moving up and down, that one is going to be called vertical translation 5, oops, not, it's just going to be 5 down. Okay. So that's what I mean by using words. Okay, so now that we have this written down, we're going to actually determine the equation for the translated function. And we're going to have it in this particular form. So remember, y and fx is already something that just represents the original function. So really, all we need to figure out is what is k and what is h. And if you remember, h basically just means the horizontal translation, and k is basically just the vertical translation. Oops, translation. Well, we kind of already answered that. We just need to put it in a number form. So horizontal translation, according to what we found, which is h is equal to 4 to the right, so that's a positive 4. K, which is vertical translation, is 5 down, so that's a negative 5. So now let's put it into that equation there. So k is, so we have y minus negative 5. So remember, just put the number right into there. And in our function, our x minus h, which is a 4. Now, since we have minus 5, so it's actually y plus 5 equals to fx minus 4. Okay, so that's what they want here. Okay, so just to summarize what we talked about today, which is just talking about vertical and horizontal translations. So note the changes that occurred. So in these particular equations, when k is bigger than 0, so k, remember, is talking about the vertical translations, then your function will be shifted up. Now, when h is bigger than 0, then you're shifted to the right. When k is smaller than 0, you are shifted down. And when h is smaller than 0, you are shifted to the left. And that's it.